Let's talk about variables, expressions, and equations. When we want to solve problems that involve quantities that we either don't know or might change over time, we use variables. A variable is a symbol. And it can be any symbol that isn't already being used in the problems that we're working with or in mathematics in general. So it can be a symbol like X, Y, and Z. These are very common. We'll often use letters from other alphabets like alpha or beta from the Greek alphabet. Every once in a while, we'll use something like just a symbol like a square. And these symbols, they stand for quantities. They stand for real numbers that we don't know or that change, or that might change. So we can use these variables to describe quantities that involve pieces that are variable. So, for example, if I want to throw a party and the room will cost $200. The room I'm getting for my party will cost $200, and the catering costs will be $32 per person. So how much am I going to spend on this party? Well, clearly that depends on the number of people that I'm going to have at the party. Because the amount of money I'm going to spend on food will be higher if I have more people at my party. I can represent this by introducing a variable for the number of people at my party. So we can let P be the number of people at the party, and if we do so, then we can express the total cost of the party in terms of the room cost of $200, the cost per person of $32, and the total number of people at the party, which is the unknown value P. So the total cost of the party will be the $200 for the room, plus the total amount of money for the catering, which is $32 times the number of people that I have at my party. So if I have 10 people at my party, then my total cost will be 200 plus 32 times 10. If I have 100 people at my party, my total cost will be 200 plus 32 times 100. No matter how many people I have at my party, this expression, 200 plus 32p, represents the total cost of my party. Now, this is an example of a mathematical expression. And an expression is one of the most basic ideas that we have in algebra, one of the most basic things that we're going to work with. So let's go ahead and define it. An expression is a combination of numbers and variables. Using mathematical operations. Operations like plus, minus, addition, subtraction, multiplication, division. We could use square roots. We can use exponents, like cubing something, or even more complicated expressions and operations. So when we combine things together, variables and numbers using these kinds of operations, we get an expression. But it's very important to note it does not include anything that compares two quantities. So this would be things like equals, less than or equal to, greater than or equal to, or not equals. These expressions, these symbols down here compare the two things on either side of them. We don't want to include those. So examples of expressions would be something like the 200 plus 32p that we had before, something like 3x plus 2. We could go significantly more complicated with it and do something like x squared plus the square root of 3x plus 1/2. That whole thing divided by x to the fourth plus 1. This is an example of a more complicated expression, but as long as you're combining things together using mathematical operations and including numbers and variables, then you get a mathematical expression. Now, it's important to note that an expression is simply a quantity. It may be an unknown quantity when there are variables involved, but it's simply a quantity. It's not a statement. It doesn't say anything. It doesn't assert anything about the numbers or the variables involved. An equation, on the other hand, does. An equation is a pair of expressions connected by an equals sign. So for example, we could take the equation 3x plus 2 equals x plus 4. Now, notice that 3x plus 2 here is an expression. It's built out of numbers and variables and mathematical operations. And x plus 4, on the other hand, is also an expression. And what an equation asserts, what an equation says, is that these two expressions on either side of the equal sign evaluate to the same number. So an equation states that the two sides are equal. Now, all of a sudden, we've gone from expressions, which are simply things that are sitting out there, to a statement. An equation states that this expression and this expression are, in fact, the same. Now, as soon as we have a statement, that statement could be either true or false. And what we find is that most equations are going to be true some of the time, and they're not going to be true other times, depending on the value of the variable here. So note that in this equation, if we consider the possible value 0 for x. If x is equal to 0, then we would then we can look at what happens when we replace x with 0 in this equation. We would get 3 times 0 plus 2 on the left equals 0 plus 4 on the right. And so we would, when we simplify all this down, 3 times 0 is 0, plus 2 is 2, and 0 plus 4 is 4. And this is a false statement. And it's false because 2 doesn't equal 4. And so if we allow x to be 0, if x is equal to 0, then this statement, this equation, is false. On the other hand, if x equals 1, then we get that 3 times 1 plus 2 equals 1 plus 4 is the value of the equation. And we get that 5 on the left is equal to 5 on the right, and this is a true statement. So what we find is that equations are statements that are sometimes true and sometimes false depending on the value of the variables inside. This would be sort of like the statement, my father is at least 6 feet tall. Well, depending on who says that, depending on who my father is, that statement is going to be sometimes true and sometimes false. For instance, if I say the sentence, my father is 6 feet tall or more, I would be lying. That would be a false statement because my father isn't 6 feet tall or more. Whereas you may be able to say that and have it be true. And some people will be able to say that and have it be true. For some people it will be false. And so it's a statement whose truth value depends on who's saying it. Similarly, an equation is a statement whose truth value depends on the value of the variables that go into it. What we are often interested in doing in mathematics in general and algebra in particular is figuring out what values for the variables will make a given equation true or not. And so we've got some language that we use to describe this, what we're trying to find. So if a value of a variable makes an equation true, we say that value is a solution to the equation or for the equation. So, for example, what we saw in the previous slide is that 1 is a solution to the equation 3x plus 2 equals x plus 4. Because if we plug 1 in for the variable, for the unknown or changing part of the equation, we get a true statement. Well, a lot of times we're interested in all of the solutions to a given equation. So we give that a name as well. The set of solutions to a given equation is called the solution set of the equation. So, for example, the solution set of 3x plus 2 equals x plus 4 is the set containing 1. Now, a couple of things to point out here. First of all, the notation that we're using. To describe a set, we write these curly braces and put all of the elements of that set in between the braces, and if there's more than one of them, we separate them by commas. We'll see an example of that in a second. However, the other thing that you may have picked up on is that when I say that the solution set of this equation is precisely the set containing the number 1, that's saying two things. First of all, it's saying that 1 is a solution to the equation. We already saw that. But it's saying that 1 is the only solution to the equation, because the solution set has to contain all solutions to the equation. Now, we haven't actually shown that yet. We haven't yet seen whether or not there are any other solutions to this equation. It turns out there aren't. It turns out that 1 is, in fact, the only solution to the equation. But we'll get to that in a little bit, and we'll see that it only has one solution for sure. Now, equations like this, which are true for some values of the variable and false for other values of the variable, are, as I mentioned, the most common type of equations that we run into, and we give them a name. An equation which is true sometimes and false sometimes is called a conditional equation. And that's because the truth value of the equation is conditional. It depends on something. It depends on the value of the variables involved. So it's an equation which is true sometimes, false other times, is called a conditional equation. So let's look at a couple more examples, and we'll have a couple more pieces of terminology to look at. Let's consider the equation x squared equals 4. And let's consider what its solution set might be. So we want to think of all the numbers that we could put in for the x and make this equation true. Now, of course, if we put most numbers into this equation, we're going to get something that's false. If we plug 1 in to this equation and get 1 squared equals 4, this is false. So 1 is not a solution. Similarly, if we try plugging 0 in or 10 in or 1.5 in or something, then we get a false statement, and so those numbers are not solutions to the equation. However, there are some solutions to this. So we have, for instance, that 2 squared equals 4. This is true. And that means that 2 is a solution. Therefore, we can include 2 in our solution set. Now, this is not the only solution to this one, because remember how negative numbers work when we plug them into exponents. If I take negative 2 squared, that means that I need to take this whole value, negative 2, and square it. Whenever we plug in a number for a variable, we have to make sure that the whole number, negative 2, goes in for the variable and occupies the place where that variable does. So for instance, if I plug negative 2 in, the way that I should try doing that is this way. And so I will write negative 2 in parentheses equals 4. Now, this is true. This is true because the left-hand side of this equation is negative 2 times negative 2, and the product of two negative numbers is a positive number. So negative 2 times negative 2 will equal positive 4, which means that this equation is a true statement, and so negative 2 is also a solution. So 2 and negative 2. Now, these are in fact the only 2 solutions to this equation. So our solution set is exactly the set containing negative 2 and positive 2. Now, it doesn't matter what order you write down the elements in a solution set. Sets don't have any order to them. So if you wanted to write this as negative 2, comma 2, the set as negative 2, comma 2, that would work out just fine. That would be just fine. And so once again, we have that x squared equals 4 is a conditional equation. Because it's going to be true sometimes when x is equal to 2 or negative 2, and false other times, for instance, when x is equal to 1. All right, let's look at another example. Let's look at x equals x plus 1. A solution to this equation would be some number we can plug in for x, where that number is equal to that number plus 1. Well, if we think about this for a little bit, we'll realize that this equation actually has no solutions. This has no solutions because no number is equal to itself plus 1. If you take any number and add 1, you always get a new number out of it. And so this equation has no solutions at all. No number could be plugged into x in this equation and get a true statement out of it, get a true equation out of it. Therefore, we say the solution set for x equals x plus 1 is, well, there are a few ways that we can write this down. We can describe it using words as the empty set. That is the set containing no elements. Or another way of writing this is using our set notation from before with the curly braces, but without anything inside. If we just write the curly braces and have it empty inside, that's the empty set. Or we actually have a special symbol in mathematics that's used for the empty set specifically, because it turns out that the empty set is important, despite the fact that it doesn't actually contain anything. So we can also use this symbol. It's a circle with a slanted line through it. Don't confuse this with the zero with a slash through this that some people use, or that you may have seen in some fonts. So we've got equation. We got an equation here with no solution at all. An equation with no solution is called a contradiction. A contradiction, from logic, is a statement which is never true. A contradiction is something that under no circumstances, no matter what the values of the variable or anything, it's never ever true. So that's the term that we use to describe an equation which can never be true no matter what the values of the variables. And then finally, let's look at a very simple equation. Let's look at 2 plus 2 equals 4. Well, this is a very simple equation, and you'll notice that this doesn't even have a variable in it. And furthermore, this equation is always true. This is always true. Because 2 plus 2 always equals 4, and there's not really anything you can do about it. We could make things look slightly less trivial by including x's in here, but just making something like 2x plus 2x equals 4x. This is also always true. Equations that are always true are called identities. Their solution set is all real numbers. And we have a few different ways that we can write this down. We can either write down the phrase all real numbers, or we can use interval notation, if you've seen that. Or we can use the following symbol, this sort of fancy R with a double vertical bar. So these are all different ways of writing down the set of all real numbers. And what this says, what it means for an equation to have a solution set of all real numbers, is that no matter what number you plug in for x, you get a true statement out of it. In either of the equations that we've got above, 2 plus 2 equals 4 or 2x plus 2x equals 4x, no matter what value you choose for x to be, you're always going to get a true statement out of it. In the first equation, that's because x changing doesn't even change any parts of the equation. And in the second case, well, this is just an identity that we're familiar with, that if we want to add two like terms together, if we take 2x plus 2x, that in fact always equals 4x. Now, there are other equations that are identities which don't look quite this trivial, and it's very interesting to find them. They usually indicate something important when we do find them. So we will talk more about how we actually find solutions to equations, how we identify contradictions or identities in the next video.